Alright, welcome back, Generals, to another Let's Fix Generals 0 Hour to make the best game ever. And today we continue with the reviews once more to try get this, well, done. Probably not yet, but maybe to some degree. Yeah, okay, so the problem I see here is I don't have a way to say it's correct or not. Like, okay, this, yeah, I guess this is correct here. The minuses. But like, for example, this, how do I know that this is correct, but this is incorrect? How do we know this? It's really not clear. Yeah, so I would say this needs to be reviewed by a Spanish native. Same story here. How we have no way of knowing if these fixes are correct. The problem is, like we have seen on the German fixes, I've seen that they were mostly incorrect. So my guess is also that most of the fixes for Spanish, Italian, and so on will be wrong. That's my guess, my best guess. It's simply based on the many errors on German, but also on English. There were also many errors, which makes me believe that this is just like lots of random like suggestions, right? Like random changes which don't know like the whole language context, right? The machine just makes a suggestion, but it might not be correct. Yeah, so I would say same thing. This needs to be reviewed by an Italian native. Okay, Brazilian. The same story. I can't say. Oops. Yeah. This needs to be reviewed by a Brazilian native. Yeah, same story here. I don't know. This needs to be reviewed by a Polish native. Okay, looks like looks like our work is done here. Yeah. Yeah. Touching some of the language is hard. Yeah. Okay, so what I can assist on is English, German. Yeah, I think for Ukrainian and Russian we will get a lot of coverage, so that's good. But yeah, Polish is big question mark. Brazilian, Chinese, Korean, Italian, Spanish, French. These languages are big question mark. And Arabic, of course, as well. Yeah. Yeah, yeah, yeah. Okay. What about this one here? Text fixes. Oh, that's the one with all fixes at once. This one will be closed, right? Yeah, let's leave it open. Yeah, let's just. I think this one will be closed after the. This pull and branch will be closed. Okay, well, I think we are done here for now. Let's see, do we have some other? Okay, how about we look at this change here? Found this. RE finding header versus library and find regex. We find these separately. Okay, let's test this again, this change. Okay, let's merge this. Merge this. Then we compile. Okay, so it does compile and find the, let's see, here. DirectX include there. DirectX library. Okay. Okay. Let's double check that this path is really the correct location. There we go. Shared. Yeah, DirectX 9 is here. And the library. The library D3, D9 lib is there. Okay. Yeah, seems to work. That's good. So it does compile and it runs as usual. Cool. Okay, nice. Now I wanted to copy that. Oh, now it's gone. Yeah, okay, anyway. It now prints include dir and linked library. Looks good. Okay, then we need to push. There we go. Let's double check the codes. Find package. DirectX. That's simple enough. And then there's this file. Cool. Find package. Imgui CMake. Ah, Imgui also needs to find it. Okay. Windows uses DirectX. No need for OpenGL. Why is this comment removed? How about we re-add this comment? Imgui CMake. There. Target link libraries. Where is it? There. Oh, oops. Okay, now we can copy this here. Okay, it compiled. Then re-add this comment, re-add CMake comment, push. All right. comment this back. DirectX required. Find package. Huh. Interesting. So if you call find package DirectX, then it somehow calls this find DirectX CMake file. Huh. Okay, interesting. Here we have done it differently. Here we have included this, but we didn't call find package. I wonder if here we should also call find package dir SDK. I don't know. Maybe. Okay, good. Then let's approve it. Then we can merge it. Do I forget anything? No. Okay. Delete branch. All right. Okay, let's delete this one. Is this the correct one? Hold on. Fetch. Delete. Right. Then let's see, what other pulls do we have left? So this one we already made a review for, and there hasn't been an update to it. It simply didn't work correctly. Okay, this one we still have. Clean up executable JSON, right. Okay, I guess I can test this here now. Right. Right, so the big question here is, what has changed now, like in the format? Does it still write out the same config format or not? Right. Let's see. So what we do is we go to data. Okay, so I guess what we do is, first I would like to see what's the diff between these guys we already have here. Let's open this path here. Okay, and then we open this one and this one. Identical. Okay. Okay, what about this one and this one? Comparison is slow. Oof. Okay, the diff is absolutely unusable. Okay, doesn't matter much. So I would say we delete these copies here and we create new copies. There we go. Then we grab the branch. What is it? Clean JSON? Yeah, clean JSON. We check it out. And we merge this one in there. There we go. And then we compile. Okay, there are some compile errors. That's not good. Fatal error. So the destructor of executable. What's up with that? Executable. Where is it? Huh. It doesn't exist. Huh. So somehow the executable constructor and destructor were deleted. That's strange. Very strange. Very strange. Okay, let's re-add this. There we go. Okay. That is fixed. Then let's run this. Then we load all files and then we save config. And then we compare. Let's see. So the size is identical. That's already good. Let's see. So select that and that. Oops. Files. Compare. Huh, identical. Huh. Oh, that is surprising. Huh. Also identical. No, that is very surprising. Okay, fix compile error. Okay, let's push. Let's look at the diff. Let me double check that really this is now. So executable types, let's see. Executable types.h, yeah, they are here. Okay, cool. To JSON from JSON. Now let's look at here, this one. Okay, let's add a to-do here. To-do, improve, how do we call it? Verify and improve error handling when a JSON field does not exist. Currently js.add will crash if that named field does not exist. Let's say should crash. Okay. PDB reader types. Can add the same to do here. Okay. Okay, so this looks very clean here. I like that. What about this one here? So that's how it's written. Yeah, okay. I see, I see. Could be some errors here. Oof. It's hard to look at this diff. Let's split this. Pass, JS pass, load JSON. Yeah. Okay, JS pass, load JSON. Load JSON. Okay. Save config. And on JSON. Pass a config file if it already exists and update it. Save JSON. Load JSON. JS contains. Let's compare this. Okay. So it seems to work just fine, but we probably need to have a closer look again at the functions. Although I remember we already extensively reviewed this. Yeah, I'm just really surprised that there's no difference in the JSON at all, which is really good, right? It's the ideal case because then you don't need to migrate anything. It's just the same result, but we have much cleaner code now. Okay, let's look at the executable class to see how it looks now. Let's see. So what we have is load config, load JSON, and save JSON. JSON section keys. Yeah, why? I do wonder, do they have to be? I mean, they could also be part. They could also be in the CPP file, but I guess here's fine as well. Yeah. Okay, so load JSON, it checks if the JSON contains the section, and then it will take it and put it in there. Yeah. It's some. Save JSON if not contains. That's if not that. Okay, let's go back here to our comments. I tested this and JSON write out appears to be the exact same as before, which is nice. Okay, then I can also maybe answer here this question. Can check if there were empty names coming from Thyme PDB via executable add symbols before. Add symbols. Let's see. Add symbol. Let's put a breakpoint here. Let's stop debugging. Let's go to debug. Put a breakpoint here. Compile. Okay, let's see. I mean, if it never hits once, it does hit. Okay, this is 0. Address 0, but it does have a name. Huh. Interesting. Where's it coming from? Call stack. Executable load. Load exe. Huh. Symbol load address 0. Why is the address 0 there? That's weird. So it's a function, it has a name, but it has its address is at 0. That's extremely weird. Why would it do that? It's all of these, no? That's stupid. No. It's all of these guys, they have 0 address. Okay, let's flick through here. How about we make a if symbol name empty, then also return, and then we remove this. This allows us to put a separate breakpoint here. Then we can check if it ever returns on symbol.name.empty. Seems not. Okay. Is it fair that if it doesn't have a name that it's not added? Probably, yeah. So before it only checked for address 0. And now it also checks for symbol name. But why was this done? Skip invalid symbols, empty name or 0 address. Would it make sense if we have a empty name? We have an address but empty name. It doesn't make sense, right? Yeah, it doesn't make sense. Okay. I don't think we need this comment here. It should be pretty self-explanatory. Okay, then let's keep it. I mean, it's not hit, so it's not change. I tested, and it is not hit on Thyme.exe and game.load. All right. Load config. Save config. Parse. Save JSON. JS. Save JSON. Let me. So save config. Yeah, J. I'm surprised that it was still write out the JSON, even if. Okay, wait. It's just reading it here. Right. No, that's correct. Yeah. I see. Yeah. Yeah. Okay. I think that's fine. Yeah, I think that's good. Then let's add those to-do comments here. Add to-do comments. Let's push that. Okay, is there any other open question? Let's see. So we can resolve this. I answered my own question here. And this one is for the to-do. So we just leave it there. And I think it's fine then, yeah. Okay, nice. Then we can set it to approve. Looks good. Looks good. All right, and then we can clean up executable JSON to match PDB and reader. How about we say improve executable, or simplify JSON codes in executable class. Simplify JSON reads and writes. Simplify JSON read and write an executable class. Yeah, I think that's good. Deletes branch and pull and delete. Yeah. Okay, then I think all the main tasks are done for this version. Now there's still this one open review here, but who knows when Johnstar will get to this? I don't know. Okay, how about we go to unassemblize pulls, and we do fix some bugs as well. I don't know. Let's set it to let's edit this. Please merge with rebase to preserve history in main branch. Preserve commits. Okay, let's change it from draft to no longer draft. How do we do that? Here, ready for review. And right, so I don't have any permissions here on this branch, on this repository, so let me ping Omniblade. Well, I hope I don't have anything sensitive. Let me see. I will censor the image for a moment. Okay, I think there's nothing secret in there. Let me get back the screen here. There we go. Okay, let me put here, please kick jobs and review. I think unassemblize review is ready. Please kick jobs and review. Note that all original unassemblize functionality is preserved. Despite the huge refactorings. Good. That was quite a big effort here to. I mean, the whole unassemblize advance was quite a big effort. I think we started beginning of October, yeah. So it took 3 months, 3 months of work. Yeah, 3 months. It was quite a lot of stuff. Yeah. Okay, but we learned a bit. Wrote 18,000 lines of code. Yeah, it's not bad. It's not bad. No. Yeah. I think it's functional right now. There probably still need to be fixes and improvements and some new features, but I think the core is there for what we want to have in the end. So I think this is now in a good state. And we can now start with the next task to work towards using it for Thyme. Yeah. Okay, so next session, what's the time? It's 1 hour just, but I already feel like I worked 3 hours. I don't know. I'm a bit overworked at the moment. It's not good. I need to take it a bit easy. So I think for next step, we should look at, let me go to my repositories here. So Johnstar has drafted a Mac-O analyzer. It is up to date. And what did he do? He wrote a bunch of classes that would read the Mac-O file. Yeah. He uses a horrible naming convention, as most people do. Mac OS segment. Mac OS segment section. Yeah, okay. So basically, this could serve as a starting point to start reading the Mac.o file. Okay, I like it. This code is pretty clean. That's nice. Get us. Yeah. So we probably yeah. So the hope is that we can get all information with this leaf library. All the information that we can get from the Mac.o file. That would be great. There's a main function. Yeah, so I don't know why. A segment is probably not very useful. Section is also not very useful. Mac.o parser. Yeah, so it gets symbols. Demangled name. But what can it get beyond that? So what is it doing? Oh, he didn't really implement it much. Okay. Yeah. So this class actually does nothing much. He did implement, oh, he just implemented like a shell of what it could be, but there's no function. Huh? I'm confused. Wait, there is section here. What is going on here? Oh, huh? Oh, so it's just like a dump. It's just like it's in here, but it doesn't do anything. Well, other than having JSON. Where? Ah, here, parser. Here does it. Somewhere. Let's see, parser. Vector, unique pointer, symbols. Why did they use unique pointer for this? Oof. Huh. Huh. Right, so here it is getting all the info. I don't know why he used make unique here. Can't he just, here we could just say like reserve segments by the size of this and then push back, right? I don't think it's necessary to use make unique here. It just it just spreads out the data into potentially more distant memory, but we want it to be tight. Like if you have tens of thousands of symbols, you want your memory to be tight so that things will be fast. Yeah. Okay, but that's just some details. Okay. Empty implementation. Okay. Mac O parser. Yeah. Okay, I think it's a good starting point. We can just try to advance this thing and try to get more information. See how far we can get. Yeah. I expect it won't be easy to. This will probably be one of the hardest parts to get all the data that we need. And then, yeah, once we have all the data, actually we should probably figure out what data we want. I think let me search for Mac O. Aha, here were some notes. Um, so list source files, global symbols, static symbols, address range for symbols combined. Global symbols are functions plus data, shows decorated name plus undecorated name. Type address shows no return type. Static symbols are functions plus data shows decorated name plus undecorated name. Type address shows no return type. Some symbols are listed twice. Ta-da, ta-da. Okay. Second file, interesting data stated object file has symbol type A. What is this? List EH files. Symbol type T, text segment function shows address plus decorated name plus undecorated name shows no return type. Has symbol type D, data segment static was shows address, decorated name, undecorated name, section, type info vtable, shows no data type. Shows no data type. Huh. Symbol type as jump table. Jump table. Inheritance. Type info address plus 8 bytes. Function return types, worst case, would have to substitute with placeholder. Perhaps at least get size of return type from inspecting assembler and do something that way. Yeah, I'm afraid that leave won't give us access to all sorts of info. So yeah, I suspect that we will get some information with leave, but not everything that we need. And then we need some other means of getting that info. And yeah, I don't know yet where this journey will lead us. I guess we just have to get started and see what we can do, and then go step by step. Yeah. Okay. I think this will be quite a bit of work. Yeah. Okay, I will take a break here. Yeah, there will be a lot of work coming our way with trying to write out, trying to get information from the Mac-O. Yeah. Okay. So I think next session we just like get started, clean up the existing code a little bit, and get like everything ready for debugging, and then yeah, step by step. Yeah. Good. Then I will take a break here. I wish you a great day or night. Until next time. Goodbye.